In this session, we would be discussing about Hadoop architecture, or we call it as HDFS architecture. HDFS architecture. Now, in this HDFS architecture, as we all know that Hadoop or HDFS is flexible with high throughput, or HDFS is suitable for applications with large data sets, and it's suitable for applications with streaming data access, and can be installed on commodity hardware, and also can be installed on heterogeneous platforms. So, this is very important platform. So, you can install HDFS on the commodity hardware. Not only that, you can have it installed on heterogeneous any platform. Yes, I can install my Hadoop on it. So, these are the best functionalities, best characteristics that you have for Hadoop architecture. So, in the last session, we have discussed few of the advantages or few of the best features that Hadoop framework has, and one among them is data locality. So, we have discussed what is data locality. Data locality is something bringing your computation locally to the data to be processed, So, what is the advantage? The advantage is bringing computation is more cheaper than bringing the data or sending the data over the network. So, what happens if I send the data? There is a chance that only 10% of the data would be sent to the computation. That is the limitation of the existing architecture that you have. So, 90% of data would die prematurely, or 90% of the data would be archived and of no use. So, in order to overcome that problem, now Hadoop has come into picture. Now, Hadoop is a medium for storage. Not only for the storage, it is also a processing medium. It's an avenue where you can store, not only store, you can process the data. So, using Hadoop, you can process 100% of the data. So, 100% of the data is available for the analysis. So, no data would be archived or no data would take a premature death. So, data locality is something, instead of sending the entire data, what I will do is I will send the logic to the data. Now, if you compare the size of the logic and the size of the data, there is a huge difference. So, sending my data makes easy to process humongous data. So, data locality is one of the best features that Hadoop has. Now, we also should be discussing about something called as rack awareness. The whole idea of using Hadoop is to store and process the data, or to read and write the data onto different data nodes which are existing on different geographical locations. So, cluster is not that I have 4 nodes in my office, and that's not, of course, we call it as a cluster, but Hadoop, you have to have a very bigger perspective. When I say Hadoop, I am accessing the data of different existing in different locations. I am sitting in, I am in India. Now, I wanted to access my cluster is across the universe, it's been across different countries. So, my other office is in United States, my other office is in Australia, my other office is in Singapore. So, from here I can access the data of different nodes of different locations. So that because that's my cluster, so Hadoop in a bigger picture, not that inside 4 walls, you have to think as if you are trying to access the data of different locations or different nodes of different continents. So when I say clusters is scattered, cluster is data scattered. Now the best point of Hadoop is, no matter how lengthy or how distant your systems are, Hadoop or HDFS works on distributed parallel programming. If you wanted to analyze, if you send the computation, it would go to different geographical locations, it would perform its operations, and data again would be gathered and total output would be produced. That is nothing but map and reduce, right? So when I say again Hadoop is HDFS for the storage and map reduce is for the processing. So we have, when it comes to data locality, yes, so different locations, I send the computation, this is the computation, and I'll perform some operation, and this whole output would be gathered and that would be sent as the final output. So that would be done by a function called as map function. So all these things would be taken care by the framework, and the final output that would be getting by the reduce function. Now here something, rack awareness is a new point come in, which is called as rack awareness. So rack awareness is something where your rack is, or your framework is aware of what is happening in your rack, or what are the different nodes that you have in your rack. So when I say, in the last sessions we have discussed about what is a node, what is a rack, and what is a data center, and what is a cluster. So now we have seen all these definitions in the previous sections. So a node is something which you place on a rack. Now what is a rack? Now let us say this is my node, and this is. So if I place all these nodes on different rack, on a rack, this is something called a rack. Now more than 2 nodes combined, we call it as a rack. So similarly, n number of racks we can have on a cluster. So these are my nodes, n1, n2 and n3, n2 and n3. And yes, if I combine more than 2 racks like this, this becomes a data center. You got my point, right? So racks combined becomes a data center. Similarly, if I have one more data center like this, a data center, a rack is a combination of nodes, and if I combine more than 2 racks, that becomes a data center. Now if you combine 2 different data centers, that becomes a cluster. So there are certain points when you write, or the whole idea of Hadoop or Hadoop architecture is reading and writing. How do you write the data onto the cluster, or what are the things that you have to consider when it comes to reading or writing or processing the data? Now we have a cluster. Inside a cluster we have racks, and on the racks we have nodes. So if I wanted to write something, or if I wanted to load the data onto my cluster, what are the things that rack awareness, or how do certain things, or how do I write or read the files, okay, onto the cluster? So the first thing would be considered is, now if a user wanted to perform read or write operations, if a user wanted to perform read or write operations. If a user has to perform a read and write operation, there are certain things that would actually influence this read and write operations onto a cluster. The first thing is the distance. Now, when you wanted to load the data onto the cluster, the first thing is it checks for which is the nearest node that I can read or copy the data, or read or write the data onto. What is the nearest node? Because name node would have, again we have to have a slight revision on the different processes that Hadoop comes with. When you install Hadoop on a local machine, when you install on your commodity machine, the 5 processes would be running. When you start your cluster, when you start your Hadoop, you will see 5 nodes are running. One is a name node, secondary name node, data node, and the 5th one is job tracker, and this is the task tracker. Now we call name node and job tracker are the master nodes. Okay, we call name node and secondary name node. NN is the name node again, and job tracker. We call these 3 processes or these 3 daemons as the master nodes on a Hadoop cluster. So we call them as master nodes, and we have 2 other nodes as well. One is the data node, another one is a task tracker. We call these 2 as the slave nodes, because you remember we have seen Hadoop, the architecture of Hadoop is master and slave architecture. The architecture of Hadoop is master and slave architecture. So you have name node, secondary name node, and job tracker. Slave nodes has data node and task tracker. Now here, if you look at the structure, the architecture of Hadoop, if you look at the architecture, now this is name node, and these are all data node, different nodes on the cluster. So we call this as a master node, and all these nodes called as the slave nodes or the worker nodes. Now we have something called a secondary name node. We also have a process called as a job tracker. Now job tracker and the task tracker would belong to MapReduce. They belong to MapReduce. So Hadoop is Hadoop is equal to HDFS plus MapReduce. Now this name node, secondary name node, we call it as SNN, and data node, they belong to HDFS. I mean to say, when it comes to storage, these 3 nodes would come into picture, and when it comes to processing, job tracker and task tracker would come into picture. So they belong to MapReduce. So they belong to, in a way of saying, map reduce architecture. So when I say HDFS, name node, secondary name node and data node, and there are two other processes. If I wanted to process my data, now these two things would come into picture. One is job tracker and the task tracker. So any information that I wanted to know related to my file system and different locations of my files on the cluster, or how much space is available, or what are the different ACL permissions that the files have. All this information I would get from HDFS or the name node, because name node being the master node of my file system, So file system, this name node would have all the detailed information about how my files have been scattered across my cluster. So my cluster. So now rack awareness, if I wanted to perform read or write operations onto my cluster, the first thing I would consider is, when I wanted to perform read or write, the first thing I would consider is the distance, because this is my rack, I have different nodes on my rack. Now this becomes a data center. Again I have similar data center. In this again I have some more racks on which I have some nodes placed. Now this whole thing I call it as a cluster. The whole thing I call it as a cluster. Here we are trying to understand what is rack awareness. What is rack awareness? So when I say rack awareness, if I want to perform read or write operations on my cluster, the first thing I've been saying is the distance. How close, if I wanted to write, if I want to load the data onto my cluster, how close my data node is to copy or write onto that particular data node. So the first thing that would be considered is the distance. So if I wanted to write, the first thing it would check whether it comes to this rack and it comes to this particular rack, or this particular data center, it comes to this particular rack, and the name node would check whether here in this node 1 whether some space available or not, If the space is available on my rack and onto the first node, I would obviously be writing on this particular node, because I don't want to go to a different location, because for example I am looking for something else, and if I can get very close by, obviously I'll definitely go to the nearest location where things are available. Similarly, if data has to be written on a cluster, first of all it would be checking for the closest node that I can perform the operation. This is very important. It will geographically check for the nearest location. If I wanted to copy anything onto the server of my company, I will not know where on particular server that would be copied, or on particular server geographically located where that particular file will be loaded. So it always checks for the nearest location. So the data is one of the factors that will actually influence rack awareness algorithm. So rack awareness, the first factor is the distance. So what it will do is it will check for the nearest location and it will try to copy onto this. Let us say if any file that is copied on a particular node of a particular rack, the framework has defined certain things. We'll understand it by the multiples of 2's. If any file copied on a node of the rack, then the distance covered is called as 0, because the rack is on this particular rack, and on the same rack I have some space where I have written some data. Now the distance is 0, will indicate the distance, or we denote that as d is equal to 0. Now if I write my file on a different node but of the same rack, or that could be this node as well, or if you have another node, any node on the same rack, any node on the same rack. Now this, the distance covered is denoted by something like this, d is equal to 2. The d is equal to 2 because we are writing the file or reading the file on the same rack on the same node. So rack is same but the node is different. Now let us say if I write on a different node of different rack, if I let us say I have this file and I am trying to write, first I have written it here on the same rack, and again I am trying to write it onto the other node, and the same file if I wanted to write on a different node, we call it as N5, but rack is different. This is different rack and this is different rack on a second rack. Now distance covered will denote it by 6. So all these distances would be indicated by the multiples of 2, So that is defined by the framework, or the people who actually invented Hadoop or HDFS file system. So if I write data on a node of a different rack but of the same data center, we call it as a data center. You remember, we call it as a data center. So data center is same but the rack is different, so the distance covered is 6. Now let us say the same file if I wanted to write on a different data center. Here not the same data center, it's a different data center, different rack and different node. Now here the distance covered would be this is d is equal to 2, then it becomes d is equal to 4. So now here distance covered is 6. So this is a different rack and altogether this is a different data center. So I am writing my file here, some node, you can define, these are all the nodes. So different data center, different rack. So distance is, we can indicate it by a multiple of 2. So this is how you first the distance would be taken into consideration. So if the user wanted to perform any operation such as read or write, the first factor that would be checked is the distance. How long your distance, what is the nearest location that I can perform my actions, because that is makes Hadoop faster compared to the existing avenues that you have. So one is the distance. The first factor is distance. In order a user to perform read and write and operations, the first factor is the distance. The second factor is space availability. Now let us say if all my nodes of a cluster are at the same location or at the same distance. So what do? They are at the same distance. Now the next factor that would be considered in order to have this read and write operations performed is the space availability. The second factor that influences rack awareness is the space factor. So how much space is available? Though it's very closer but there is no space available, obviously I have to look for another node or on the same rack or another node on a different rack. So here, yes, the node is very closer. This is node 1, node 2 and node 3, node 4, node 5, node 6. So if I don't have space on this particular node, obviously I have to check for the another node for the availability of the space. Though the distance is same, but if I wanted to write but no space is available, so obviously I have to go for another node or of the same rack or another node of the different rack. So second factor that actually influences the rack awareness is depend on, first is the distance, next is the space availability. This is to perform read and write operations on a cluster. Understand, we are trying to perform read and write. That's what we do on a cluster. You load the data, you write the data, you read the data, you perform some analysis. So before we understand how actually the read and write would be performed, we have to understand something called as rack awareness. So if I wanted to read or write anything on my cluster, the first thing that would be considered is the distance. Second thing, the space availability. Now the third thing is the third factor that actually influences read and write operations is, let us say my distance is same and also have the space available on different machines. Distance is same, I have the space available on the different machines. The second factor would actually influence this write and read operations is the RAM of the systems. So RAM of the systems, RAM of each system. So RAM of each system, because while doing the read and write operations, there is a bit difference between a RAM, a system with 1 GB RAM and a system with 100 GB RAM, because we are trying to the whole idea is we do install Hadoop on the commodity hardware. Commodity hardware may have different RAMs for the different systems. So there would be a difference when it comes to read and obviously read and write operations would obviously RAM plays a crucial factor when processing the data. So there would be a huge difference between a system with 1 GB of RAM and a system with 100 GB of RAM, isn't it? So RAM also makes a difference while reading and writing the data onto the cluster. The first factor is the distance, second factor is the space availability, the third factor is RAM of each individual system, and the fourth factor is fourth factor is network speed. The fourth factor is the network speed. In order to have your data transferred, over the network speed also makes a lot of difference, because if you wanted to transfer the data from one system to another, if you wanted to transfer the data from one network to another, if you wanted to transfer the data from one location to another location, the network speed also makes a huge difference. So we call it as the velocity factor. Velocity factor can also be considered. So the first factor is distance, because read and write operation, the transmission of the data, so network speed. So one is the distance, second one is the space available, and the third one is the RAM, and the fourth factor is the network speed. Now let us say I have all these things set for a cluster. So distance is very less, and I have the space available. Okay, I have the space available. I have a good RAM of each individual systems, and the next network speed is also very good for the cluster. The fifth factor that contribute to this rack awareness is node availability. So though distance is very close, you have good systems with huge amount of space on each individual system, and your network speed also very good, and all the systems do have a good RAM specifications. But the factor that also influences this rack awareness is node availability. If you need to have the nodes available on the cluster in order to perform read and write operations by the user. So here imagine we have a cluster and I am a user. I want to do read and write operations, either read or write operations onto the cluster. So if I wanted to perform, my framework would check something called as rack awareness. Now these are the factors that actually influence rack awareness. So what rack awareness is something, what is happening on the RAM, what is there existing on the RAM. The first factor is the distance. In order to user perform read or write operation, the first thing is it considers the distance, how close the node is, So the first factor would be taken into consideration is the distance. Next is how close is the system, or how geographically how closer you are to that particular cluster or particular rack or particular node. The second factor is space available. Now I found a node which is very closer. The next thing I have to check, or next thing is the space available in order to read or write. If I want to load the data, also check the distance. Yes, I found a system. Next is whether the space is available or not. So if space is available, that's very good. The third factor is if I wanted to read the data, if I wanted to process the data on each individual system, RAM also plays a huge important role, because there is a difference between a RAM with 1 GB of RAM, a system with 1 GB of RAM, and a system with 100 GB of RAM. So there is a difference. So RAM also plays a crucial role. Next is the network speed. So yes, I have a cluster in which all these things are connected. So network speed, in order to have my data transmitted, so the good network speed actually contributes to the faster processing. The next thing is, the final factor is the node availability. Though all factors are good, but if I don't have a node available, then I cannot do any read or write operation. The next thing is we have to think about is, let us say, as we all know that in Hadoop architecture, there is something called as replication of the blocks. So in HDFS, each file would be broken in form of blocks or small chunks. We call them as blocks. And the block size in HDFS is, as you know, 64 MB. So now on a cluster, let us say, where do I have to place the blocks on a cluster? Where do I have to place the blocks or this chunk of data on my cluster? So let us say, is this visible? Okay, let me take this off, or else I'll write it later. The sixth factor that you have to consider is, where do I have my block placed? Because HDFS files blocks, and each block would be replicated 3 times on HDFS. The replication factor, we call it as replication factor. Replication factor of HDFS is 3. That means each block on a node would be replicated 3 times on a cluster. So what is the advantage, what is the disadvantage, we will be discussing about this. But to understand the final factor, which actually where on which the rack awareness is dependent on, is how you place the blocks on a cluster. Let us suppose I have placed my block 1 here, I have placed block 2 here. Let us say I have one more node on this rack, and I will place my block 3 also here. So is it a good approach? No, isn't it? Why? Because if this rack goes down, my entire data is lost. The final factor which actually influences this rack awareness is where you place the block on a cluster. where you place the block on a cluster. So I have different nodes on my rack and different blocks. I'll break each file in the form of blocks. So each block, it is always a good practice to place each block on a different rack, or at least one block on a different rack. So that's when the concept of high availability would come into picture. So if anything happens to this block, no problem, this block is available. If this also goes down, immediately we will have the data on this block 3. So in generally in production environment, you don't see any things happening like this, but this also influences the concept of rack awareness. So each block would be placed on a different rack or a different node on a cluster. So remember the factors that actually influence this rack awareness, or the rack awareness is dependent on, the first thing is the distance of a node, second is rack awareness. Rack awareness is dependent on distance of the node, and the second is space availability on a particular rack or a particular cluster, and the third one is RAM, and the fourth one is network speed. So to perform read or write on a cluster by the user, and the fifth factor is node availability, and the sixth is how you block replication, how you replicate the block of data on the particular cluster. So these are the certain things very important. In interviews they would ask you about what is data locality and what is rack awareness, and what are the factors that actually influence rack awareness.